Hello, welcome again to Special Maths Academy. My name is Honor Pius. This video we're looking at IMO 2022 problem 2. So this is an algebra problem. So functional equation, we just need to point out some things. So first we're dealing with positive real numbers, and so we have this functional equation, or more precisely this functional inequality, because we have functions and we have inequality instead of equality as usual. And also once we fix a value of x, then we see that y, we don't get to really choose what y should be. Okay, so this is kind of unusual, which suggests that we might want to consider the converse of this, which suggests proof by contradiction might be a very good way to go about this. Also, we have that this inequality is symmetric, so we'll be making use of the symmetry as you see fit. Okay, so with all this, we can move on. Now, first of all, let's fix x. So x is a positive real number. Then we see that there is a unique y that satisfies this equation. So a unique y that works. So when we say y works for x, what we mean is that y satisfies this equation once we have that given x. Okay, and otherwise we can say that it doesn't work, or we could just say that y fails for that particular x. So this makes y a function of x, because given any x we can uniquely determine y. So we can write y as some g of x, and the domain and codomain would be, of course, positive real numbers. So we can write g from r plus to r plus. Okay, so let's get some particular characteristics of this g. So we see that y works for x if and only if x works for y. And this is based on the symmetry of the inequality. So given we can swap x and y and we just have exactly the same inequality. And so in terms of g, this means if y is g of x, then x is g of y. And so g is an involution, meaning that if we operate g twice, we get back the identity. So this means it's particularly injective and surjective as well. Okay, so now we'll deal with our first claim, claim 1, which is a claim about g. So the g is actually just a trivial identity for every x. So to do this, we'll be using proof by contradiction as suggested earlier on. So we're going to assume otherwise, and then we hope to get a contradiction. Okay, so that means the converse of this is that there is a particular x where g of x is not x. Okay, so what this means is that x doesn't work for x, meaning x fails for x. And this means that it doesn't satisfy that inequality we're given. And so since it doesn't satisfy the inequality, we have to go with the reverse of that inequality. Okay, so we're going to end up with when you set y equal to x in that inequality, we get this, but now it's going to be reversed because it fails. And this is actually a very strong point, which makes this functional equality actually good, because if it were equality, the converse wouldn't be so nice. So now the converse is also a regular inequality, though it's strict this time. Okay, so with this we can simplify and make f of x subject by just collecting like terms and dividing by 2x. So we get that f of x in this case will have to be greater than 1 over x. Okay, so in a similar way, and this actually works because x is positive, so we don't have to worry about directions of the inequality. And in a similar way, we can get the same result for g of x. That's because since x is an evolution, as we showed before, we can write it as such, and meaning we can look at this as though g of x is a new value for x. So everything we did before is actually just going to follow. Okay, so from that we can just jump to the conclusion, which is f of that to be 1 over that, 1 over g of x. So now we have two inequalities facing in a positive direction, which is actually in contrast with the initial inequality, and makes it easy to now combine the two. So to do this, we have to go with inequalities that faces the opposite direction. So pick g of x, which works for x, use that as our y, and then we have this inequality. So with this now we can actually combine it with the two inequalities we got earlier. Okay, so we add g of x over x. Okay, so this is all nice because we're working with positive numbers, and now we can now use AMGM inequality to show this is greater than or equal to 2. So this means that 2 is strictly greater than or equal to 2, and this is, as it turns out, a contradiction. Okay, so this in conclusion, we have that g of x has to be equal to x every time. So what does this mean? It means that x works for x, right? So we can now use the appropriate inequality, which is x f of x is less than or equal to 2, and similar to what we did before, just simplify this and we get less than or equal to 1 over x. Okay, so now we'll move to the second claim, and the idea here is that it seems to make sense that f of x probably would be 1 over x. So we're going to prove that next. So claim 2, we have f of x is 1 over x for all x. Okay, so once again we're going to use proof by contradiction because that gives us more information. Without that, it's going to be difficult making any reasonable steps forward. So by assuming the converse, becomes easy for us to have control over what works and what doesn't. So in this particular case, we assume f of x is not equal to 1 over x. So we're going to be making use of equation star. Okay, yeah. So before we move on, we're going to substitute a value of y that doesn't work. So we take y to be square root of x over f of x. Okay, later we can see why this would be a good choice. And so once we set this, we can verify that y will not be equal to x. Assuming it's equal, we get a contradiction, of course. So this means that y is not g of x, so it fails for x, meaning we can now use the reverse inequality for y. So we're going to just simplify this in a straight line. So there are going to be three major parts to this: y f of x, Okay, is equal to 2. So greater than 2. So we have because y fails for x, we have that strict inequality there, and then this second equality is coming from star applied to y. And then the first one is just equality, which by solving would have given us the y we need, right? So that's actually what's suggested using that exact y. So that's like the minimum point if we draw that as a curve. So this gives us this inequality which goes contrary to star, and so that's our contradiction. Okay, so with this we can conclude that f of x is equal to x for every x positive. Alright, so now you may think we're done, but now almost. That's because it's possible that there are other conditions that might make this not actually work. So we're going to plug this in and see if it satisfies the condition in the problem. Okay, so we have this inequality. Now we're assuming f of x is 1 over x, so we get this regular inequality, which is which we can actually solve based on AMGM, but we can just expand this outwards, take LCM, cross multiply, and then we can actually collect terms and factorize. So, and since we're dealing with real numbers, this is only possible when this is 0. So y is equal to x. This is a unique value for every x,